Hi students, this is Sudhir Kumar, IIT faculty physics from NEET JEE Doctors Academy. So I just would like to pose some problems here and test how it works today. So these are the homework questions that I've given yesterday and day before yesterday. So one of the questions I just would like to discuss here. In this diagram is saying that the string is pulled here, okay, towards right with velocity v. Then what will be the velocity of this block moving horizontally, he wants. So when you are pulling the string with velocity v, in this concepts we always take inextensible strings. The strings will not extend. So that is why every particle of the string will be moving with the same speed here v. So one end is moving with velocity v means every part of the string will be moving with velocity v only here. Understand? So therefore, now if this v dash is the velocity of the block, this is 90 minus theta. The component of this v dash I can take here now. How much is that? V dash cos 90 minus theta, isn't it? So this is v dash cos 90 minus theta. So this component v dash cos 90 minus theta must be equal to this velocity v only now. So therefore v dash cos 90 minus theta is equal to v. Therefore v dash cos 90 minus theta is sin theta. This will be v dash is equal to v by sin theta. Therefore the velocity of the body horizontally is nothing but v by sin theta. Okay. So this is another problem I just would like to solve for you here in this case. Now you see if this fellow is pulling this string, towards him like this with speed u. My tension will act always away from this fixed point or away from the body or where. This is a tension and here is a velocity. Right? And if this is the tension here is everywhere you'll have the same tension T, 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 T. And here also T, here also T. Right? Here also T, here also T. And here also T, here also T, here also T. Because in one string you will maintain the same tension in magnitude. So this is a one string, no? Isn't it? So everywhere tension will be same. You all know, you studied when I am explaining. And directions of the tensions will be changing, but only one tension you will have. Okay, let us consider now the other part of the string which is present here. Now here the tension will be here 2T now. So here also it is 2T. So here also the tension will act away from him, which is 2T, and the velocity is this side. Now, okay, if you consider here, this is 2T and T, here the tension will be 2T, and here also consider here T plus T, tension will be 2T here. On the whole, this block already you have a 4T tension acting upwards. So let this block is going upwards with velocity V now. I would like to apply sigma T dot V is equal to 0 now. So first for the block if you take, you can see, okay, you can see here the mass of the block is m, tension is T, velocity is E. I want sigma T dot V, of course TV cos theta, and but tension and this V are in same direction, so 4T into V I have to write, okay. So this I have to write 4T into V, so 4T into V, right, plus, so again we have to consider in this case here, this part you have to consider. There you can see tension and velocity are in opposite direction. Here also tension and velocity are in opposite direction. So therefore now minus I should write here, isn't it? So therefore minus Tu I'll write. Minus Tu I'll write for this part. And for this part is minus 2Tu. So is equal to 0. So this is an expansion of this equation. Okay. This is now 4TV is equal to 3 times Tu. So tension gets cancelled. So velocity of the block now here is equal to 3U by 4. So 3u by 4 is the velocity. Okay. Now one more problem I want to discuss. See, in this problem now, he want the acceleration of capital M. We want the acceleration of capital M. So for this block we want acceleration, right? Now let us draw the tensions here. See, same concept. In one string you will have only one tension. So therefore let the tension over here is T. So therefore in this string everywhere the tension will be T only now. This is T, 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 this is T. And again this is T, this is T, this is T. So if you consider on this block M naught, so here you will have a tension 2T, here you will have a tension 2T. So totally 5T force is acting upwards for this M naught. For this M naught only. So 5T is acting upwards. Let the velocity is V, accelerations, okay? Acceleration is A1. So I would like to use sigma TV dot is equal to 0, not TVA, TA dot is equal to 0. So now shall I apply now 5T into A1 I write. So 5T into A1. Next, if you come to this block here, you know this is a tension is upwards and we can consider this block is going downwards with an acceleration A2. So 5T_A1 for the mass M0 and for mass capital M, you know, I can write minus T into A2 is equal to 0, that's all. So therefore this is 5A1 minus A2 is equal to 0, 5A1 is equal to A2. Suppose if A1 is equal to A, then A2 will be equal to 5A. That's what we can understand here. So now I'll draw free body diagrams now. So I want few more equations. I'm not getting A1 and A2 directly here from this. So another equations also I want. So if I take this capital M here, capital M means mg will be acting downwards, tension will be acting upwards. Finally, it is going down with an acceleration A2. So apply Newton's law. Now capital M into g minus t is equal to capital M into A2. But what is A2? It is 5A. So therefore I'll write mg minus t is equal to m into 5A. Let me take this equation as 2 now. Now I'll take free body diagram of this M0 also here now. Okay, let us see. Now you are having M0 here. M0 G is acting downwards, 5T is acting upwards, and finally it is going with an acceleration A1. So if I write the Newton's law here, 5T minus M0 G is equal to M0 into A1. Of course, A1 means I have already taken as A. So M0 into A. Okay. Now this is another equation 2, 3. Now solve equation 2 and 3. For example, you can multiply this equation 2 with 5 so that you will get 5 mg, 5 minus 5t, 5 5 is 25 I'll get. And when you add these two, know that 5t and this 5t will get cancelled, and from that you calculate A. After calculating A, he wants acceleration A2 now. So A2 is nothing but 5A you have to calculate. So after calculating A, you calculate 5A. That will be the answer. Now coming to this problem now, the last problem. Okay. These are our questions from material only. Just few questions which I have given homework the last week. I am just doing it here. Now here also our single string story. This is a single string here. So therefore everywhere the tension must be same. So therefore the tension must be here T, here also T, here also T, here also T, and here also T. So in this part the tension is T. Observe that point very carefully now. Now I'll take the pulley here separately. So now here the T is acting downwards. Here also T is acting downwards because here the tensions will be downwards. And according to our pulley concept, when mass of the pulley is neglected here, the tension over here must be 2T. But according to our concept, the tension here is T. So which one is correct? 2T is correct or T is correct? See, this in order to satisfy this both conditions, I have to take tension 0 only. See, the tension here is 0. If the tension here is 0, then tension here also becomes 0. If it is 2t, also becomes a 0. So if in order to get 2t and t, two answers, then I have to take t 0. Then only it is possible. Therefore, if the tension is 0, so that means there is no force on the block A. If we take block A, you have a T is acting upwards, isn't it? When this tension is becoming 0, it becomes a freely falling body. Now, for freely falling body, acceleration is g. If you come over here, the tension is 2t here. And if you take the block B here, here the tension must be 2t. But if you say t is equal to 0, this force also is not there. Then it is also a freely falling body. So both block A and B are freely falling bodies and both will have acceleration g and g. Therefore, the both blocks have same acceleration. Okay.